a 4-wire smoke detector with a removable base. This is the one that we use the most, or at least the System Sensor i3 brand is what we use the most as replacement devices. So you have 2 positives that come in. You have your 2 negatives that go to that terminal. You have your signaling circuit in and your signaling circuit out, and your signaling circuit in and your signaling circuit out.
That's more than 4 wires.
Yes, it's 8. Because it is 4 wires to run the device, and if it was the only device in the system, then it would only need 4 wires. But you're going to continue your circuit on to the next one. So the way that this ends up working is we have 3 smoke detectors. On our fire panel, we have 1 zone. And this is how most of 4 wires are supposed to be put in or are put in. I'll talk about both because almost nobody ever does 4-wire correctly. The idea of 4-wire is that you could get more stuff onto the loop because you would power all of the devices first and then run your signal circuit back through them. So you could power more detectors on 1 zone than you can with 2-wire, because with 2-wire you're using just 1 pair to run both the signaling and the power to the devices. With 4-wire you're using a pair for power and a pair for the signal that comes back to the panel. But we're going to use 1 zone to do it because we are dumb people in the early 90s and that's how they did everything. So we have our power that passes through each of our smoke detectors. And then it comes out. On a normal circuit, this is where we put our end-of-line resistor if it was 2-wire, right? With a 4-wire circuit, this is just providing our power to our devices. So this pair of wires is running through just these. We still have to actually hook up to the contacts, the normally open and the common, for when this device goes into alarm to short. So what we need is a relay. This is the thing that is usually missing. On our relay we have common, normally open, and normally closed, and we have power. Relays can be activated for lots of different things. There's different kinds of relays. This is one of the little black ones that's got the wires hanging out of it. And so the way this relay acts or behaves or switches state is when it has power, when it does not have power. If it doesn't have power, then it flips. It's just like a light switch. So we're going to run our power into the relay. When this relay is normally running, it has power, it is going to have a short between common and normally closed. So we're going to take that, take our positive, go into here, and then come back out. So that means that if for some reason there's a wire break on the power line, this is going to change state and open the circuit, which creates a trouble, right? Opens our troubles. If we don't have this relay, which 90% of the time that you find 4-wire stuff, they don't have the supervision relay. So if you cut the power, the smoke detectors all go dead, but the system can still see the end-of-line resistor.
Mm-hmm.
Oh, through the signaling circuit?
So the circuit stays normal.
Okay.
So just so that this is easier to look at, these are the same 3 smoke detectors. After we come out of here, we're going to go through our signaling circuit, our normally open and our common contacts on each of these. And then go back to the panel. Often when you open up the panel and you see an end-of-line resistor, you see that old, it's red, and it looks like lamped zip cord. And you'll see a pack that goes out and then it comes back and it's got a resistor on the end of it. 90% of the time that you see that is because they're using 4-wire devices and they ran the whole circuit out to a relay, hopefully, and then brought it back, and then they put the end-of-line resistor in the panel, which means that when you're troubleshooting it, you're not looking for the end-of-line resistor. You're trying to find where that relay is because you're Your end of line resistor is not the end of your circuit.
Mm-hmm.
So all of this gets powered, goes through this relay so it can supervise whether or not the power is being lost to the circuit. Then it comes back through and gets all of our signals, or gets our for our signal terminals, which gives us our shorts if we go into alarm. Most of the time that I find them, this guy doesn't exist, and all we have is this. And so, if we lose the circuit somewhere, it doesn't have the same level of supervision. The devices just lose power, and the system's like, okay. I wonder if I should let anybody know. Oh, I can't tell anyone. So if the one that I found the other day that I sent you guys a picture of, the problem with it was my relay was here. We'll just do that. Not worry about drawing it all out and everything. But my end of line resistor was there. And so, if, let's just say, which I fixed this, but let's just say that while all of these bases have their terminals and everything and the smoke detector's plugged in, you can't really disconnect it from its connections unless you take the smoke head down. If you take the smoke head down, you're going to lose the power and you're going to have an open on the signaling side, so the panel should go off. But if some general contractor is screwing screws through walls and they didn't put nail plates in or anything to protect the wire, and he hits the wire and he happens to cut it here, are we going to get in trouble with the panel?
No.
No, because the resistor here is completing the circuit for the panel and it's not paying attention to anything that's going on down here. So if you find your relay and your resistor at the same device, you need to check the system to find out whether or not you have two separate circuits. Because it is totally okay if you do have that situation, if this is being run off of aux power or resettable power. And this is zone 1 or 2 or whatever. Then it would be totally fine. Because, well, actually you probably wouldn't see the relay because aux power is not supervised. Yeah.
What if it'd be end of line going the other way?
So you'd have your end of line here. Because the power is not supervised, there's no way to, resettable power on a panel that isn't a supervised circuit, so if you put a resistor there, the panel's not looking for trouble on it. But you can power 4-wire this way as well, and that's perfectly fine. There's no supervision of this power circuit. The hope is that the supervision of the signal circuit will pick up when the detector goes dead, then it should still give a trouble to the panel. But if you're using the same terminals to power the devices and to signal, then you need to loop back through and you need to have the relay at the end. Does that make sense to everybody?
Yeah.
At least the alarm people?
Big series and parallel circuit.
Can anyone give me a good reason why we should use 4-wire today?
No.
None?
To charge the customer more for the copper, the wiring, really run up the cost of the job.